Hello everyone. Today in this video we are going to talk about 7 dimensions of nature, and we will learn to derive the dimensional formula of different physical quantity. So if I ask you what do we measure with a scale, so your answer would be length. So it can be the height, it can be a thickness of any object, it can be a radius of a circle, it can be hypotenuse of a triangle, or it can be the breadth of a cube. So while measuring this quantity, we are measuring the length. So I can denote height, thickness, radius, hypotenuse or breadth by a general term length. If you take the formula for density, which is mass by volume, I can simplify the volume as V is length into breadth into height. And as we already know, length, breadth and height all are length only, so the volume can be represented by length into length into length. Similarly, force, so I can simplify acceleration into velocity by time. Again, velocity can be simplified into length by time. So again I got length by time, so I cannot simplify it further. Similarly, if you take kinetic energy, so half n mass I cannot simplify, but velocity I can simplify. Velocity is length by time, and this is the basic. Now I cannot simplify further. Now if you see all three quantities, the similarity between these three quantities are they can be represented by using mass, length and time. So their formulas are different, but when you simplify them, you can represent them by using just mass, length and time. So this mass, length and time are basic quantity. So now let's talk about the different types of physical quantities. So there are two types of physical quantity. One is fundamental quantities and another is derived. So fundamental quantities are quantity which do not depend on other quantity like length, mass, time, amount of substance, electric current and temperature, and luminous intensity. So it is the measurement of intensity of light. These quantities cannot be further simplified, but derived quantities are those which depends on this basic quantities like speed, force and work. So we can simplify this quantities into basic quantities. So there are two types of physical quantities. 7 dimensions of physical worlds are the fundamental quantities. So we represent length by capital L, mass by capital M, time by capital T, amount of substance by MOL, mole, electric current by A, temperature by T and luminous intensity by CD. These are the 7 dimensions of physical world. Now dimension of a physical quantity means the powers of fundamental quantities. Like suppose I have speed. Speed is distance by time. So for distance I can write length, and for time I can write t. So the dimension of speed is L to the power 1 and time to the power minus 1. Similarly, if you take the circumference of a circle, the formula is 2 pi r. So 2 pi does not have any unit, so but radius is length. So circumference of a circle has dimension of L to the power 1. Dimensional formula. So in dimensional formula we'll write the powers of fundamental quantity, but we include m, L and t. So see, for acceleration I can write this is velocity by time, and velocity is again distance by time. So if you simplify this, you will get distance by time into 1 by time. So it is length by time square, and I can write L to the power 1 t to the power minus 2. When you take this up, it will become t to the power minus 2. So in dimensional formula I have to include mass also. So I'll write m to the power 0 because mass is not there. So if it is not there, I'll write just power 0. So dimensional formula of acceleration is m0 L1 t minus 2. So it's important to mention M, L and T whether they are there in the formula or not, or we have to put them in a square bracket. So now let's take the angle. The formula for angle is arc length by radius. So arc length is length and radius is also a length, so L will get cancelled, so we'll get 1. So that means it does not have any dimension, so it is dimensionless. Angle is dimensionless, so I'll just write M0 L0 T0, because to write M, L and T is very important. Dimensional equation. So dimensional equation will equate the physical quantity with dimensional formula. So like for area, it is length into breadth. Length can be represented by L and breadth is also represented by L, so it is L square. So to write the dimension, I have to include M, L, T also. So there is no M and no T, so I'll just write 0, 0. So dimensional formula of area is given by, so I'll put area in this square bracket is equal to the dimensional formula. So this is the dimensional equation. Now let's find the dimensional equation for density. So density is mass by volume, and volume can be written as length into breadth into height, and mass is there and there are 3 lengths, so length cube. So I'll take this length up, so it will become M1 L minus 3, but I have to include T also. So dimensional equation of density is equal to M1 L minus 3 T 0. So it's not necessary to write 1, so you can skip the 1. So for force is mass into acceleration, so I can write M is equal to, acceleration is velocity by time, so this is again velocity is distance by time. So here I have 1 mass, 1 distance and 2 times, so M L by T square. So if you take T to the numerator, it will become -2. So dimensional equation of force is M1 L1 T minus 2, and this dimensional formula for force is very important, so I want you to memorize this M1 L1 T minus 2, because it will help us to find the dimensions of other quantities. Now for charge, we have to have the formula in which charge is there. So we know the formula, current is charge by time. So from here you can find the dimension of charge. So you can write charge is equal to current into time, and dimension of current is A and dimension of time is T. So dimension of charge is M0 L0 T1 A1. So to write the dimensional formula, it is necessary to include M, L and T. So if it is not there, we'll put 0 power. So for potential, so we know potential is work done by charge. So for work done, I can write force into displacement. Now I told you to memorize the dimension of force, so it will be easy for you to find the dimension of other quantities. So for force I know M1 L1 T minus 2, and for distance it is L, and for charge we have just done before, that is AT. Now I'll simplify this, so it will become M1 L, there are 2 L's, so L2 and T minus 2 and minus 1, T minus 3 and A minus 1. So dimension of potential is M1 L2 T minus 3 A minus 1. So similarly you can try this question. So pressure is force by area. So momentum is mass into velocity. Kinetic energy is half mv square. So for half there is no dimension, you have to do m and v square. So you can find the dimension of resistance using Ohm's law, and you can find the dimension of gravitational constant G. So you take this formula and take G this side, so your G will be equal to Fr square by m1 and m2, and m1 and m2 are masses, so their dimension will be m and m, so don't write m1 m2 for them. So for electrostatic constant, again for K you can find, so K is equal to Fr square by q1 q2, so put the dimension of all the quantities you will get, and the capacitance, that is C, is represented by Q is equal to CV, so you can write C is equal to Q by V and put the dimension Try this question and let me know if you have any problem.